So that's a great question. Thank you for that. Actually, we wanted our customer to feel as light as an antelope. And because if you are a marketer or a website owner, data analytics can be so far away from you and so a heavy thing. And we want to make that easy to consume so you feel light with your data as the antelope, and you will be able to take decisions so quickly and fast as this amazing animal. I hope it answers your question.
Beautifully, Eynav. Go ahead with your presentation.
Thank you. Thanks everyone for joining. It's so great to be here, and I'm super excited to share my thoughts about how to prepare your system to scale. So I'm Eynav. I'm leading the amazing group of R&D at Oribi for 2 years now, but my real job is being a mother for these three amazing kids at the picture. And today I'm going to talk about scale. But you know, sometimes it feels like everyone talk about scale, right? We hear it from all around. We read about it, or post about it, lecture about it. Scale around. I'm here to talk on a different angle that is not mostly discussed, and that's the part of the system that cannot be easily auto-scaled. Why I'm telling you that? I'm telling you that based on the experiences we had at Oribi. So let's take a moment to explain what is Oribi and why we are having scale and handling such amounts of data. Oribi is about codeless data. We track events on our customer's website. We actually capture everything without any sampling. From these events at our backend, we create large data layers that describe everything that happens on the website. In a structured way, we modelize that in a way that we can create insight on top of it. Once we have the insights, we can create visualization that our customers can easily get from our application and dashboard. And eventually, our customers can export this data and leverage that in different and other third-party integration if they want to base their campaigns on that or create audiences based on this useful data. You can read more about Oribi at our website, but now let's go back to our main focus, and that's scale. So as Oribi is about creating data layer, we have a large amounts of data. At the past year, we started with 100 million of incoming events a day, and then in 1 month, we just jumped to 300 million events a day. And actually, there was a 1 hour that we just had an increasing scale peak of 10x in 1 hour. And that was a huge thing for a startup, for a system that is a bit new at the neighborhood of big data and scale. And although we have auto-scaled microservices-based architecture, and we had like a great optimized infrastructure, it was still a struggle. Why? Because we had different angles and different technologies to handle. We had the AWS cloud provider services. We had a Kubernetes cluster to handle and manage through this scale. We had our microservices, Apache Kafka, Elasticsearch, Apache Druid, Spark, so many data solutions that we need to handle and manage in such a huge scale peak. That was not easy, but we did some great stuff when we designed Oribi that helped us to manage that scale and to be at the place today when I can share that with you and tell about that in a success way of the story. So here you can see the scale peak at 1 hour, as I mentioned, we had 10x of incoming traffic to the system. But what's more important that in overall, due to the success of the business, we also have incremental scale each month. If you add the incremental scale that we had monthly, Along with the huge scale peak that we experience in 1 hour and combine it, you get a lot of stress and high increasing scale on the system from different directions. How to prepare and how we prepare. Again, we're a small startup. We don't have a lot of engineers. We're new in this neighborhood. So first, get ready for tomorrow today. My first advice to you, if you are in a place, even if you are a start company, or if you are a big company, try today to examine your system. And I'm gonna advise you with 3 pillars that I think that if you will examine your system according to them, you can really manage your system throughout the scale. I wanna illustrate that, okay? If you have just $100 and you need to take decision to prepare your system, to design your system, and you know that eventually there will be scale because you hope that the business will succeed. You have a lot of solutions that will cost you $10 and 2 solutions that will cost you $50. What will you do? Will you pick many solutions that cost $10 because you only have $100, or will you go to the solution of the $50 and you will have just 2 solutions that are more expensive? I'm telling you that because this is the decisions that you take, especially when you grow out your business. And my advice to you, don't hurry up to take the smaller $10 solution and maintain the $50 solution on your table. I know they're more expensive, but it might pay off. I'm going to examine that and explain that more in a bit. 3 pillars that can help you plan your system out for scale: elasticity as a mindset, batch methodology, and isolation verification. Let's see each one of them. Elasticity. My main focus here is that auto-scaling is not enough. I see many engineers saying that their system is so great because it can auto-scale. And as we go to data solutions, it's not so easy to auto-scale. Most of the time, if not always, you will need to do manual actions to scale out your system. It won't be automatically. And that places that exactly the spots that will harm and hurt while scaling up. Here is an example. On Oribi, we're doing a heavily usage with Apache Kafka because we need all our system to be very elastic, and we manage our messaging and traffic, incoming traffic, in asynchronously way. So what we do, we have a large clusters of Kafka with a lot of brokers, and we had a playbook saying when the scale will go up, we will just add another broker to our cluster, to our Kafka cluster, and just then we can scale out the cluster easily. And here we solve the scale problem. We won. But what happened in real life? In real life, when the scale got so increasingly high, the brokers were very loaded. Their CPU almost reached 100%. On that stage, the cluster was loaded and busy. When we added a broker, we needed to do an action to balance the data to the additional broker that we just added. Such action takes CPU as well. So it's loading the cluster behind its current load. If we would do a balance in such stage, the total cluster will just collapse. So we couldn't do anything. We couldn't scale out because we couldn't rebalance the cluster with the new brokers that we just added. And that's an issue. What we should have done, we should plan the playbooks better and start scaling out before the cluster reaches the point that we can't really do any other actions like rebalancing the cluster. So first, I advise to you, locate non-elastic components at your system. Usually these are databases, data stores, message queue, or even network components like load balancer, or other badly planned services at your architecture. Such services are really hard to auto-scale, so you should be aware of them and plan their elasticity accordingly. Consider the ability of each component to scale not only according to the compute resources, CPU, but only consider memory, storage, I/O, concurrency, and the network when you plan the metric that you will help you to take decisions of when to scale out or when to scale back in. The next pillar is batch processing. When I was a young engineer, I thought that batch processing is like a luxury tool for us in the engineering team because it seems to be such an expensive solution. But it's not. That's the tool that can really help you to grow and to manage scale when the scale increase. Let's see that in a live example. Here is a data solution. Let's assume it's a data store and many services that ingest right into the data store in real time. Think that there's now a load and scale, and all the services write a lot of data to the data store all at once. The thing that the data store have a limit of I/O, mostly or all of them will break in some point. So you will get services fail to write to the data store, or badly, the data store will get to some point when it's not available or even collapsing, crashing. What you should do in that case, you can add a batch component. So the services will not write directly to the data solution, but there will be a middle proxy component, and you can handle when the ingestion is happening, when the processing is happening, and when to actually write to the data store, and it won't be done in a full real-time process. So when load increasing on your system, streaming is hard to control, and it's more complicated to limit. The cost and complication of changing your system architecture to work with batch processes can pay off, especially on that spots. But if you think that you will be handling scale in some point, even in 4 years from now, think of batch processing ahead of time. This is something that should be really considered and designed, because if you would like to add it once you have some scale drama or issue in the system, that will be the last magic trick to pull from your hat, because it's not something, it's not a straightforward thing to do. You need to take action to make it happen. The third pillar is isolation, or let's say how to avoid starvation. Here is another example. At Oribi, our customers have dashboards. These dashboards are ran through a React application, a state-of-the-art application that what it does eventually talks with a backend service that queries our data store data solution. So when there is a customer that might have a lot of data at Oribi, when he loads or she loads the data throughout the dashboard, it will create a large query on top of our data solution. If you add a scale to that, a scale of writes, scale of reads on top of that same data solution, eventually it can create a starvation on other customers. So other customers might open their application and get timeouts or wouldn't actually load Oribi application because of that. So we avoided that by locating places where our system components are not isolated and defending them accordingly. The parts that are of risk of starvation will be the first to get blocked by those users that have a lot of amount of data. And this is something that you need to consider. If you are in the early stages of business, a starvation situation might sound like a fair way possibility to you, something that is not really close to you. However, you should challenge your mind to imagine the effects of scale on your system, leaving the starvation possibility on the table. And even if you can't really get prepared to that at this point, at least have a plan or at least design how to fix it later on. So we talk about elasticity as a mindset, batch methodology, and isolation verification, three pillars that can really help you prepare your system to scale. I want to talk on another amazing thing that is super, super important. It's not one of the pillars because it's really related to each one of them, observability. When it comes to observability and data solution, services, application, you need to be able to understand what's going on with them to detect the scale on time. Especially when you are a growing startup and you're still small, you probably don't have the resources to invest in creating a large batch processing mechanism and auto-scaling methodologies, have full elasticity in your system, right? You don't have the resources, maybe you don't have the knowledge, or maybe you don't have the time. So in that case, at least invest in observability. When I talk on to when I mention observability, I refer to many metrics. It's not only the CPU and memory that most of the time we check and examine. There are many, many different categories, metrics that you should use to explore your system ability and your system health. CPU and memory, of course, I/O network, storage, concurrency, and even more depends on your system. For example, if you use message queues, RabbitMQ, or Kafka, you probably would like to measure the lag. If you are using a data solution with hot tier, you would probably want to measure the average query time. Such measurement can give you a higher observation of the system health. But I talked about systems. So I want to give you an example of observability on top of system and not only on specific data solution. Because when we do an ad hoc monitoring, for example, on your Elasticsearch cluster, on your services, on your Kubernetes, this is something that is really scope. We need to also monitor the system so we would be able to understand how the components behave with each other once the scale is raising up. Here is an example. You see here an example from Oribi monitoring system. We're using Grafana and Prometheus. As I mentioned, we have a lot of incoming data and some interesting metric that we are using in our ingestion chain that digest a lot of data in real time. It's the end-to-end processing time. This is super important because eventually if I measure every different component separately, I might see that there is some load on the Elasticsearch cluster. There's some spike on the Apache Druid cluster that we're using. There's some memory or CPU consumption that is not so regular on Apache Kafka cluster, but I won't be able to connect all the dots. Here on this metric, we are measuring end-to-end processing. That helps us to connect all the dots because if there is some scale on the system, if there is a delay on the system and it's affecting the system health, this number will increase rapidly. And that can help us take conclusion fast, to react fast, and to prepare fast, especially the parts that cannot be auto-scaled and require some manual action. That was it. We talked about the three pillars: elasticity, batch processing, isolation. And on top of all of that, observability, because we need all the time to understand what's going on with the system, even if we don't have still all the best practices and methodologies. We handled everything that I mentioned into Oribi, and we had a great experience. We improved the technology from scale to scale. And I'm wishing you to scale up your system, because eventually it means that your business is succeeding. You have more customers and more traffic, and that's a good sign. I will be really happy to discuss with you in the chat room, and you feel free to contact me in the LinkedIn. I hope you enjoy that. Thank you very much.
Thank you, Eynav. We still have time, about 9 minutes. I do not see any questions on Discord. So people listening in, do ask some questions. And while we wait for questions, I have one for you, Eynav. So you use a lot of technologies that in the end are using JVM. So is JVM startup time a concern while you were doing your scaling?
Can you repeat that again about the JVM, please?
So you're using a lot of technologies which I assume are services in Kubernetes using virtual machine. So like, you mentioned Spark and a few other things in there. So when you're scaling up, your instances, JVM instances, have to pay the cost of JVM startup. Is that been an issue for you during your scaling?
So first, I think that's a good question, because you're also taking in account the actions that are being done when scaling out, right? We're adding another service, we're adding another, if it's in Kubernetes, another pod or another instance, and this instance probably needs to get some Docker running, JVM running. This is the exact thing that I'm talking about, taking all the actions that requires while adding another instance while scaling out, until it's really ready to accept new requests to digest new data. We take this in advance, so our scaling decisions are not being done when we reach the 95%. It means that the system is kept in utilization that gives us enough space to act on time. I will give an example. I mentioned the Kafka. So it's same for Java services. If you would decide when the current services reach a concurrency of 95% to add another instance, to add another service instance, it's probably too late, because as you mentioned, there's the warm up of the JVM, and it might take time until the machine is ready. So it won't be ready on time, and request might fail, and you might even lose data. So my advice on that is to put the metrics in a threshold that will give you enough time to act. It's probably 95, it's bad, 100% is worse. So you probably should be kept in around of 80%, 85. Some companies even do 60 because they know that there's a heavy lift of the warm up of the system, and they want to be able to behave and act on time.
Excellent. Yeah, that's definitely something to remember. We cannot scale at the edges. You have to scale early. And like Eynav said, quickly. So I do not see any more questions. When you were scaling up and learning all these lessons, did you get increased cost for a little while?
Yeah, we did get an increased cost. For example, some of our machines were running on spot instances, so Spot instances are AWS instances that are temporary. You don't have a guarantee of the time that they will be up running live. Hence, there might get down after a while, after a few hours, after a few minutes, you can't really know. And on some parts of the system, such behavior created instability. Because if you take, for example, Elasticsearch and running that on instances as spots that are not all the time live, and even though you have a replica factor that ensures that the data will be replicated on more than one server, even though once the spot was down, one server of the Elastic went down and the whole cluster took time to get through it, and we had a bad instability in the system. So one action that we do is to replace spot instances for the Elastic cluster and for more data solutions that must be stable and can't handle these downtimes. And that cost us, because this kind of change from moving from that type of instances to instances that are on demand but are all the time there but are most costly affect our costs. That one thing. And the second thing, we did add more resources to the system, but the good thing is that we have the ability to scale in, not only to scale out. So once the scale was done and the system was mostly stable, we could really quickly optimize back where needed, and to increase resources where it wasn't really needed to be with high resources or with really large instances. I hope that answers your question.